Hello. Once again, the Center for National Distance Learning and Open Schooling, CENDLS, brings you another core mathematics lesson for SHS2. My name is Betty. We are going to discuss two very important concepts in mathematics in our next few lessons, beginning from today. The two concepts are indices and logarithms. You must learn how to pronounce these words. Today, we shall look at indices and the associated laws of indices. By the end of the lesson, you should be able to write the repeated factors of a number in exponent form, state the laws of indices, and use the laws of indices to solve problems involving repeated factors. Now, you have learned in your junior high schools and in the year 1 that numbers can be written as repeated factors. For example, 8 is equal to 2 times 2 times 2, which can be written as 2 to the power 3 or 2 to exponent 3. Again, 125 can be written as 5 times 5 times 5 or 5 to exponent 3. Also, 49 can be written as 7 times 7 or 7 to exponent 2. We also have x times x times x times x to be equal to x to the power 4, or m times m times m times m times m times m times m to be equal to m to the power 7. Now, in the first example, 2 to the power 3, the 2 is called the base, and the 3 is called an index or an exponent. Again, in the last example, the expression m to the power 7 or m exponent 7, m is called the base and 7 is called the index or the exponent. Can you find the exponent and the bases from the following examples? Examples 2, 3, and 4 that we mentioned earlier. Very good. Now you will see that in example 2, 5 to exponent 3, the base is the 5 and the exponent is 3. In example 3, we had 7 to the index of 2. And the base is the 7, the exponent is 2. In example 4, x to the exponent 4, the base is x and the exponent is 4. Well done. Now, when we write a number in the form x to the exponent y, we say that the base is x and the exponent is y. And when a number is written in that form, it is said to be in index form. The plural form for index is indices. And so we will define indices as the process of writing numbers as a base and an exponent. Now let's write the following numbers or letters in index form, and in each case, identify the base and the exponent. Example 1. We have 9 times 9 times 9 times 9 times 9. I'm sure you've got the answer. It is 9 exponent 5. The base is 9 and the exponent is 5. Again, we have 0.34 times 0.34 times 0.34 times 0.34 times 0.34 times 0.34 times 0.34. And that gives us 0.34 raised to the power 7 or to the exponent 7. Once again, the base is 0.34 and the exponent is 7. Let's look at the next one. We have n multiplied by itself 7 times. And so in index form, we are going to have n raised to the exponent 7. Then our base is n and our exponent is 7. Now we have 10 times 10 times 10 times 10. In index form, that gives us 10 raised to the power 4. And so our base is 10 and our exponent or power is 4. Once again, we have 2 over 3 multiplied by itself 6 times. In index form, that would give us 2 over 3 raised to the power 6. The base is 2 over 3 and the exponent is 6. Good. I hope you got some of these correct. I'm sure you can always write repeated factors as a number in index form. It is very easy. Now, many times, there's the need to simplify expressions in maths. And so in maths, numbers written in index form can be simplified using basic rules, which we call the laws of indices. We're going to look at some of these laws so we can use them later. So let's look at the following products. Now, anytime you have to multiply a long row of repeated factors, like the ones we are going to see, we can write them in index form, and then we can add their exponents. So let's look at these. The first example says 3 times 3 in one bracket times 3 times 3 times 3 times 3 in a second bracket. We can remove the brackets and multiply the whole row of numbers. That would give us 3 times itself 6 times. I'm sure you can count them. And so we will write that as 3 raised to the power 6. On the other hand, we can write these numbers in index form. So the first brackets give us 3 raised to the power 2. And the second brackets will give us 3 raised to the power 4. And so we will say that 3 raised to the power 2 times 3 raised to the power 4 is equal to 3 raised to the power 6, which we got in the first part. What we are saying here is that if you are multiplying 3 raised to the power 2 by 3 raised to the power 4, the easiest way to get your answer is to write the base, which is 3, and add your powers. So you get 3 raised to the power 2 plus 4, and your answer is 3 raised to the power 6. I hope you understood that. Let's look at another example. We want to multiply 5 times 5 times 5 times 5 times 5 in one bracket times 5 times 5 times 5 times 5 in a second bracket. Now, like we did before, we can put all the multiples of 5s together, and that will give us 5 times itself 9 times, which is equal to 5 raised to the power 9. On the other hand, we can write each bracket as index numbers, and then we multiply. So that will give us 5 raised to the power 5 times 5 raised to the power 4. Now we are saying 5 raised to the power 5 times 5 raised to the power 4 is equal to 5 raised to the power 9, which we got earlier. Now by this, we are saying that if you have to multiply 5 raised to the power 5 by 5 raised to the power 4, you can just take the base, which is common to the two numbers, write it down, and add your two exponents. So you have 5 raised to the power 5 plus 4, and your answer is 5 raised to the power 9. which is a much shorter way of working this question. Now let's look at the C. We have 3 brackets. In the first bracket, we have 2 multiplied by itself 3 times. In the second bracket, we have 2 multiplied by itself 6 times. And in the third bracket, we have 2 multiplied by itself twice. Now to work these, we can remove the brackets and multiply all the 2's. You will find that we are going to multiply 2 by itself 11 times. So that gives us 2 raised to the power 11. On the other hand, we can write each of these brackets as index numbers. And then we can multiply. That gives us 2 raised to the power 3 times 2 to the power 6 times 2 raised to the power 2. And again, we will say that that is equal to 2 raised to the power 11. Once again, you can use the short form for working this question. Put down the common base, which is 2. Then add the exponents. So you get 2 raised to the power 3 plus 6 plus 2. And that gives us 2 raised to the power 11. Now from these examples, we've seen that 2 raised to the power 3 times 2 raised to the power 6 times 2 raised to the power 2 is equal to 2 raised to the power 3 plus 6 plus 2. And again, 5 raised to the power 5 times 5 raised to the power 4 is equal to 5 raised to the power 5 plus 4. Also, 3 raised to the power 2 times 3 raised to the power 4 is equal to 3 raised to the power 2 plus 4. We can then conclude that if you have to work a raised to the power x times a raised to the power y, you will take the base, which is a, write it down, and add your exponents to get x plus y. This is one of the laws of indices, and that is the multiplication law. As we go along, I want you to keep these laws in mind because we'll be using them to work a lot more questions. What we are saying can be translated into this, that 2 raised to the power 9 times 2 raised to the power 11 will give us 2 raised to the power 9 plus 11, which is 2 raised to the power 20. So you see how easy it has become. We want to find 10 raised to the power 12 times 10 raised to the power 5. Take the base, which is 10, write it down. Add the powers, 12 plus 5. So you get 10 raised to the power 17. Again, we want to work 11 raised to the power 9 times 11 raised to the power 8 times 11 raised to the power 13. Take the base, 11, write it down. Add your 3 exponents. You get 9 plus 8 plus 13. That gives you 11 raised to the power 30. Also, if we want to work d raised to the power 3 times d raised to the power negative 8 times d raised to the power 10, we will write down our common base, which is d, and add our powers. What are the powers here? 3 plus negative 8 plus 10. And that gives us d raised to the power 5. So what if we have to work b raised to the power p times b raised to the power q times b raised to the power r times b raised to the power s? It doesn't matter whether your powers are numbers or letters. The same thing has to be done. So take the common base, b, write it down. Add all the powers. So p plus q plus r plus s. And put them in brackets. Now we want to look at quotients. Once again, you might be required to divide long expressions of multiples of factors by another one. And so we have a shorter way of working it. We want to look at this. This time, we have 3 multiplied by itself 7 times, divided by 3 multiplied by itself. Now, we can cancel out some of these terms to simplify the expression. And when we do that, we'll get 3 multiplied by itself 5 times. And so our answer is 3 raised to the power 5. On the other hand, like we did in the previous part, we can write the 2 expressions in index form, and that will give us 3 raised to the power 7 divided by 3 raised to the power 2. So we find that 3 raised to the power 7 divided by 3 raised to the power 2 is equal to 3 raised to the power 5. Now the short form of working this, write down the base and subtract your powers, and you get the same answer. We want to divide 5 multiplied by itself 7 times by 5 times 5 times 5. We can cancel out the terms. And when we do that, we end up with 5 raised to the power 4. On the other hand, we can write 5 raised to the power 7 divided by 5 raised to the power 3. Now, this is supposed to give us the same answer as we got before, which is 5 raised to the power 4. And so we say that the short form of working this question is to write down the base and to subtract your powers. And so you have 5 raised to the power 7 divided by 5 raised to the power 3 to give you 5 raised to the power 7 minus 3, which is 5 raised to the power 4. Again, this is a much shorter way of getting your answer. Now, what if you have 7 multiplied by itself 9 times divided by 7 multiplied by itself 6 times? Again, you can take your time and cancel out. And when you do that, you get 7 raised to the power 3. You can also write them in index form. Now, in index form, we are going to get 7 raised to the power 9 divided by 7 raised to the power 6. And these two are supposed to be the same. That tells us that the answer to that question should be 7 raised to the power 3. So once again, use the short form, which is the law we are talking about. You take the base and subtract your powers to get your answer. From these examples, we have seen that 7 raised to the power 9 divided by 7 raised to the power 6 is the same as 7 raised to the power 9 minus 6, which is 7 raised to the power 3. Also, 5 raised to the power 7 divided by 5 raised to the power 3 is equal to 5 raised to the power 7 minus 3, and you get 5 raised to the power 4. Again, 3 raised to the power 7 divided by 3 raised to the power 2 gives us 3 raised to the power 7 minus 2, and our answer is 3 raised to the power 5. We conclude that if you have to divide a raised to the power x by a raised to the power y, take the common base a, write it down, and subtract your powers. So you get a to the power x minus y. That is another law of indices. We call that the division law of indices. Now, examples are y raised to the power 12 divided by y raised to the power 5. To get your answer, we take our common base y, write it down, subtract our powers. So we get y raised to the power 12 minus 5. And that gives us y raised to the power 7. And therefore, we are saying that if you are dividing an index number by another index number, take the common base, write it down, and subtract your powers. That is the shortest way of getting your simplified form. Now we want to look at when an index number is raised to another power. For example, you have m cubed raised to the power 2. M cubed raised to the power 2. Now we know that when we raise the power 2, it means we are multiplying something by itself. So m cubed raised to the power 2 means we are multiplying m cubed by another m cubed. Now we can write this as repeated factors. But we can also use our first law to just work m cubed times m cubed. And that will give us m raised to the power 3 plus 3, which is m raised to the power 6. And therefore, we are saying that m cubed all squared is equal to m raised to the power 6. When we have an index number raised to another power, the shortest form of getting our answer is to write the base and to multiply our indices or powers. Another example is 7 raised to the power 5 all cubed. 7 raised to the power 5 all cubed. That means we are multiplying 7 raised to the power 5 by itself 3 times. We can use the first law to work this. I hope you remember, we take the base. Because they are multiplying, we add the powers. That will give us 7 raised to the power 5 plus 5 plus 5, which is 7 raised to the power 15. And so 7 raised to the power 5 all cubed is equal to 7 raised to the power 15. The short form is write down your base and multiply the indices or the exponents. So anytime you have an index number that is raised to another power, so you will find you have brackets, 2 powers. What you do is you write down the base and you multiply the powers and you get the same answer. Now, from the examples we have looked at, we can conclude that if you have x raised to the power m or raised to the power n, this will be equal to x raised to the power m times n, or x raised to the power mn. This is also one of the laws of indices, and we say this is the power of power law. So, for instance, you have to work 5 squared or raised to the power 4. What do? Write down your base. Because there's one power outside the bracket and one inside the bracket, it means you have to multiply your powers. So you have 5 raised to the power 2 times 4, and your answer is 5 raised to the power 8. Again, 9 raised to the power 7 or raised to the power 4. You can see we have brackets. One index is inside the brackets, the other one is outside the brackets. So you take your common base, 9, write it down, and multiply your powers 7 and 4. So our answer is 9 raised to the power 28. Now, there are also some properties of indices that will also need to help us when we are working questions on indices. One of them is the negative exponent. So let's look at that. Now, supposing we divide y multiplied by itself 4 times by y multiplied by itself 8 times, and we cancel out. We are going to have 1 over y times y times y times y, or 1 over y raised to the power 4. On the other hand, we can use the second law of division to work this question. That will give us y raised to the power 4 minus 8. That gives us y to the power negative 4. So we are saying that y to the power negative 4 is the same as 1 over y to the power 4. You should be very careful here. One has a negative sign, the other one does not have a negative. But it helps us to be able to change our exponents from negative to positive. This means that y raised to the power negative 4 is equal to 1 divided by y raised to the power 4. Once again, we want to divide 9 multiplied by itself 4 times by 9 multiplied by itself 10 times. You can cancel out. You end up with 1 divided by 9 multiplied by itself 6 times, which is 1 over 9 raised to the power 6. On the other hand, we can use the division law to work the question in exponent form. So we have 9 raised to the power 4 minus 10 to be equal to 1 over 9 raised to the power 6. Now, 9 raised to the power 4 minus 10 gives us 9 to the power negative 6. And that is equal to 1 over 9 to the power 6. Again, it means that 9 with a negative exponent 6 is equal to 1 over 9 with a positive exponent 6. Once again, we can conclude that a raised to the power negative m is equal to 1 over a raised to the power m. Good. Remember, when you put 1 over a number with a negative index, it changes the index to a positive index. And we will use this as well as we go along working questions and indices. And so if you have y raised to the power negative 8, you can quickly change it to a positive index by putting 1 over y to the power 8. 7 raised to the power negative 5 is equal to 1 over 7 to the power 5. I hope you got that as well. There's one other thing that you need to know. This symbol is called the radical sign. And the expression 2 under the radical sign is called the square root of 2. It can also be written as 2 raised to the power half. Again, the radical sign with 5 under it is called the square root of 5. And it can also be written as 5 raised to the power half. When we have a small 3 in front of the radical sign with the 8 under it, we call it the cube root of 8. It can also be written as 8 raised to the power 1/3. Now, many times the radical sign is not very friendly with students. So you can easily change it to become a fraction when you are working indices. Now, supposing we have a small 4 with the radical sign over a raised to the power 3, it is called the 4th root of a cubed. Now, this can be written as a cubed raised to the power 1/4. And then we can use one of the laws that we learned to multiply the powers. So this becomes a raised to the power 3/4. So let's look at the last property, and that is 0 as an exponent. Now, anytime we raise a number to the power 0, it's equal to 1. For instance, if we have 3 raised to the power 5 divided by 3 raised to the power 5, you know that any number divided by itself is 1. And so here, we should get 1. We can also use our indices to work it out. And that gives us 3 raised to the power 5 minus 5. That will give us 3 raised to the power 0. So we say 3 raised to the power 0 is equal to 1. Now, any number raised to the power 0 is equal to 1. And the opposite is also true, that any time we have 1, we can write it as another number raised to the power 0. Now we want to use all that we have learned to work some questions. Remember, the reason for all that we have learned is to be able to solve questions on indices. Now, for each question, you may have to use more than one of these laws. So let's look at the first example. It says 5 raised to the power 2 or raised to the power 4 times 5 raised to the power 8 divided by 5 raised to the power 3 times 5 raised to the power 6. You want to simplify this expression. Good. So we'll use the law of powers for the first part. That will give us 5 raised to the power 2 times 4. And that gives us 5 raised to the power 8. So the question changes to 5 raised to the power 8 times 5 raised to the power 8 in the numerator. And then in the denominator, we have 5 raised to the power 3 times 5 raised to the power 6. Now we'll use the law of multiplication for the numerator and then for the denominator. That gives us 5 raised to the power 8 plus 8 divided by 5 raised to the power 3 plus 6. Now simplifying further, we'll get 5 raised to the power 16 divided by 5 raised to the power 9. Now we are going to use the law for division. So we get 5 raised to the power 16 minus 9. And our final answer is 5 raised to the power 7. Now in the second question, we have 13 raised to the power 5 or raised to the power 3 times 13 squared raised to the power 4 divided by 13 raised to the power 10 or raised to the power 3. So again, we will start by using the law of powers for each of the terms. That gives us the first term to become 13 raised to the power 5 times 3 times the second term in the numerator, that becomes 13 raised to the power 2 times 4, which is 8. Then in the denominator, we'll have 13 raised to the power 30. Now, we will use the multiplication law for the numerator. And then finally, we'll use the division law. So that gives us 13 raised to the power 15 plus 8 divided by 13 raised to the power 30. And that will be equal to 13 raised to the power 23 divided by 13 raised to the power 30. Now, using the division law, we will subtract the powers. So we get 13 raised to the power 23 minus 30. And our final answer is 13 raised to the power negative 7. But we don't want to leave our answer with a negative exponent. So can you remember how we change that? We're going to put 1 over. So that can be written as 1 over 13 raised to the power 7. Good. How do you find the simplifications? I'm sure you think it's easy. All you have to do is know your laws and know your properties and use them at the right time. Now let's look back and recap our ideas from today's lesson. We have seen that indices is the process of writing a number as a base and an exponent. Again, that a number written in index form looks like A with an exponent x, where A is called the base and x the exponent. Again, we saw that the laws of indices can be summarized as follows. A to the power x times a to the power y is equal to a to the power x plus y. And a to the power x divided by a to the power y is equal to a to the power x minus y. Then a to the power m all raised to the power n is equal to a to the power mn. We also saw some properties of indices. And the first one says a raised to the power negative m is equal to 1 over a raised to the power positive m. And the nth root of a raised to the power m is equal to a raised to the power m over n. Finally, a to the power 0 is equal to 1. Well, students, we have come to the end of our introductory lesson on indices. I hope this has been fun for you. Remember, keep practicing so you don't forget. And in the next lesson, we will continue from where we left off. Bye-bye.